Hello, everyone. Welcome to our newest webinar. I'm here today with Professor Alexandre Jacquillat. He teaches Analytics Edge to the Master of Business Analytics students, as well as MIT Sloan MBA students, and various other students in the graduate school. So welcome, Alex.
Thank you.
So we would like to start off by just having Alex describe his background and give a little bit of introduction to yourself.
Sure. Hi, everyone. So my name is Alexandre Jacquillat. I'm an assistant professor of operations research and statistics here at the MIT Sloan School of Management. And prior to that, I'm originally from France. I graduated from the École Polytechnique in 2010, and then I came to MIT for my PhD. I've been on the faculty at Carnegie Mellon University for 3 years prior to coming back to MIT at Sloan for last summer to teach the Analytics Edge and a couple of other things. Other than that, I'm passionate about analytics. I think that it's a very exciting time in society for really leveraging all the amounts of data that are becoming available to individuals and organizations. And it's exciting to be in this environment where I get to work with a lot of students who share that passion.
Great. Could you just go back to when you were a student here at MIT?
Mm-hmm.
What did you study and what was your dissertation?
Right. So I came here at MIT as a master's student, and then I stayed for the PhD. I did my PhD in engineering, what is now the Institute for Data Systems and Society, IDSS. My work was basically at the intersection of analytics, transportation, and public policy. So I was very interested in understanding how we can leverage data on operations in transportation systems in order to make better long-term decisions when it comes to planning, scheduling, and then operations. And specifically, I looked at air traffic management systems. So I worked with airlines and airports in order to understand how we can design better scheduling algorithms that basically bridge the gap from data to actual decisions in terms of, again, scheduling and operations. So a little bit of like analytics methods to translate data into decisions, and a little bit also of business and policy in order to understand what is the right question and how to best answer it with analytics methods.
Great. Was there a specific airline or airport that you worked with?
All airlines, but specific airports. At the time of my dissertation, I worked mainly with the data from the New York airports. We had also a partnership with the Port Authority of New York and New Jersey, which is the organization that manages the airport systems in New York City. And since then, I've been working also with a number of airports internationally, in Portugal, in Brazil, and in France, as well as in Singapore. And
a lot of airports.
It's a lot of airports, and they are all very different. So it's also very interesting because when you travel, you realize that all these different airports, in this case, all the different organizations are not managed in the same way. They don't obey the same regulation. They don't have the same practical constraints, and that lead to new technical challenges because the problems are not the same. Therefore, we need new methods to address the different challenges in practice. And that's really the interplay of analytics and practical decision making. It's like it's a two-way street. We need more methods to address more problems, but at the same time, when we travel, when we meet new organizations, we realize new problems that will then feed analytics.
Yes.
And that's really what I've been very excited about. So I work with a lot of airports. I'm also now developing relationships with airlines, and we're going to have a couple of projects this year.
Wonderful, thank you. So then after MIT, what made you go to Carnegie Mellon University?
So after MIT, I actually spent a little bit of time in consulting first. I worked for 1 year in analytics for McKinsey & Company.
McKinsey, yes.
And then I learned a lot about different domains of transportation as well as different applications of analytics. And then I came back to academia because, very simple, I love research, I love teaching, and I got to work with amazing students who were very passionate about, again, analytics broadly defined. So that's been just terrific. I was at the Heinz College for Public Policy and Information Systems at Carnegie Mellon University, and I was teaching in a program in Information Systems and Management and Public Policy and Management, which basically share a lot of characteristics of business analytics.
Yeah.
And then I just came back this summer to MIT to teach.
Awesome.
Thank you.
So going to your teaching now for this semester, can you tell us about the course that you're teaching?
Of course. So I'm teaching the Analytics Edge. It's one of the core courses of the Master of Business Analytics program. So we can talk more about how that fits into the broader curriculum, but basically all incoming students in the first semester will take a number of courses in machine learning, optimization, and the Analytics Edge. The purpose of that course is to demonstrate, number one, the vast array of possible applications of analytics methods in practice and how organizations and individuals can get an edge in decision making through better use of analytics methods. And number two, how to do that, how to apply analytics methods compellingly for different data sets and different problems in practice. So what we're doing a lot of is trying to understand the problem, trying to look at the data that we have, and then trying to bring analytics methods in order to address that problem well. So we're starting very easily with linear regression models, and then we're making it a little bit more complex, and we're going into decision trees, random forests, we're doing some clustering, and then we're going all the way to deep learning. So we're going to learn methods, but with a problem-driven, data-driven approach, as opposed to just learning the methods more theoretically.
And how do you decide which problems the students
I'm trying to solve for diversity. I mean, that's the beauty of analytics. There is a huge array of applications, never ending, right? If we think about transportation, if we think about healthcare, if we think about marketing, if we think about even sports, if we think about telecommunications, all these industries have been profoundly revolutionized over the past 10 years, 15 years, 5 years in some cases, by more and more data, by better and better methods, by more computing power, and also by managers that are becoming more analytics savvy, that see the value of analytics and therefore will empower their organizations to leverage data and analytics. So the purpose of the course, in a sense, is to give a sense of that diversity. And so in order to do that, every week, or actually twice a week, every lecture, we're going to have a practical problem and a data set that comes from one of these sectors. So over the past couple of weeks, we looked at finance, we looked at sports, we looked at healthcare, we looked at smart cities, we even looked at wine, how to understand a wine market. So really solving for diversity.
Great. And so can you tell us the format of your lecture? Are you talking about, is it mainly just you speaking in front of the students, or what is the format of your class?
We're trying to be interactive, so they are like basically different elements of a lecture. As I mentioned, the course is extremely problem-driven. So we're starting with a problem. So we're starting with a business context. So I'm presenting a case where, for example, a sport organization is trying to hire better players, or a healthcare organization is trying to understand better how to treat a patient early, given the information that we have about this patient. So talking a little bit about the context, and then we have a conversation in class about, hey, what are the drivers of these decisions? What are the data that you would like to have? What are the considerations that come into your mind? And then we're kind of drawing that perfect picture of the perfect data set that we would have, and then we're trying to see, hey, what's available in there? And then I'm presenting one data set that I have to provide, and then we're trying to say, okay, with the data that we have, what can we do? So that's the first part. And then the second part is, okay, now let's teach a method in order to see how we can make the best use of this data set. And so here, we're going into a little bit more, I would say, traditional lecturing about a method. And then there are a lot of questions because the students really want to understand not only like the theory, but they want to understand how they can apply the method to the data set that they have here and the data set that they may encounter in the future.
Got it. And so what kind of preparation does a student need going into your class? Do they need some prerequisites, or do they have to do a lot of reading or coding?
Not that much. The main prerequisite that is helpful for the program, let's say, not that class, is to have a background in probability and statistics, and if possible, optimization. If we know a little bit of these things, then we can actually have more fun doing it. So specifically, the only thing that I would assume is that the students would have seen, for example, the basics of linear regression in the past. test, right? So
Mhm.
if a student knows regression, a student knows then the basics of statistics, the basics of statistical inference, and the basics of prediction. If we have that, then we are going to do a quick review of that, and then we're going to go into like more advanced methods. Some students think that, oh wow, I have to know so many methods. No, that's the purpose of the program. The purpose of the course is to introduce these methods. So I'm not too keen on imposing very sharp prerequisite. Like basic statistical knowledge is more than enough. But the main prerequisite will be a passion to learn methods, learn implementation of the methods, and make a difference through analytics. And as long as the students have that, I think they would be very successful in the class and in the program.
Okay. And so for the implementation part, what programming languages do you use, and do they need to know programming coming into the class?
Good question. As I mentioned, so we're doing a class that is extremely problem-driven, and in order to get the full value of that, we need to implement the methods, right? We don't want to do only whiteboard. We want to actually get the results and analyze results and communicate results. That's really the purpose of the class. To do that, we need to implement the methods using a computer program. What I'm using in the class is twofold. I'm using R for all the statistics and machine learning, R, and I'm using Julia and Jump for optimization, which is something that is becoming very popular for optimization. The purpose of the class is not programming, so we're not wedded to any particular method in general. We're just using that as a means toward learning, toward our end, which is learning analytics and its applications.
Okay, and can you describe Julia and Jump a little bit for those students out there who might not know those two languages?
Yeah, I mean, so Julia is the programming language. It is something that's extremely flexible and have a lot of capabilities, very easy to learn, much more so than other similar programming languages. Jump is an optimization solver. So the main benefit for the class of using Julia is that we can have access to an optimization solver that is extremely powerful, and that enables us to solve large-scale problems. I mean, by cloning like the solvers of CPLEX and regularity and this type of things, that can help us solve very large-scale problems through very easy programming tasks and a very user-friendly interface. And there is no prerequisite here. The purpose of the class is to teach it, and actually the students in the first week of the programming orientation will actually learn the basics. So that makes it very easy during the class.
Wonderful. And so going through all these methods, do you have a favorite method?
I mean, there has been a lot of work recently about decision trees and their variants. Also talk about forests and boosting for trees and these type of things. What I'm trying to emphasize in the class is that prediction has many different objectives, and the typical one is trying to solve for accuracy or predictive performance. I want a forecast that is as accurate as possible. What I'm trying to argue is that it's only one side of the coin. There are other objectives, and one of the other objectives is interpretability. And I think that now that analytics are becoming more and more widely used in practice, it's absolutely essential to have decision rules that are interpretable by human decision maker. We cannot have algorithms that's just black box that will give you a decision and then people will implement it. It's not going to work. We need the human decision makers to trust the algorithm, to trust the results of analytics. And to do that, the best way is to make the results very interpretable to a human. And decision trees do that. They will mimic human decision making, and at the same time, usually achieve very good predictive performance. So we're going to cover that next week. So hopefully the students will agree with me.
Okay, wonderful. And can you talk about the grading methodology? Are there exams in the class or homework assignments? How does it work?
We have no exams, and we have homeworks that are roughly one per week or one every 2 weeks for the whole semester. We have like 7 or 8 homeworks for the entire semester, so once every 2 weeks on average. And we have a term project. So it's basically roughly evenly divided between homeworks and the term project in terms of overall grade. What we want is for the homework to make sure that people know how to implement all of the methods and to tackle a practical problem and to actually go through basically all the questions that they would face in a job. So here is a problem, here are the data, what do we do about it? So then it's guided because it's homework, but it's not only about applying the methods correctly, it's also about asking the right question and communicate the answer to a human decision maker. So I ask a lot of questions about write a memo to your manager to report your results and this type of things, because they're going to be analytics professionals, and the technical part is only basically half of the story. There is another half of the story. And then we're doing a term project where basically the students basically have fun in, I mean, or that's the goal, trying to tackle a problem that they are interested in. And then I'm extremely flexible. So in the past, we had projects about like how to make predictions regarding which beer is going to be more popular, or which investment is going to yield the highest return. I mean, there are like a huge array of possibilities. And what I want is to create a low risk environment as opposed to a capstone project or a job. To create a low risk environment where the students can explore a data set that is interesting to them, try different methods, and report what they learned.
Okay, and so this term project goes throughout the course?
Yes,
and they work in teams?
Yes,
or?
They work in teams of four, especially during the second half of the semester. I mean, I asked them to think about them from the first week onward, but the emphasis on the term project is, so basically the first half of the semester has more of an emphasis on homework assignments, and then I'm reducing a little bit the amount of homework assignments, and the students will work a little bit more on the term project.
Okay. And is there a textbook for the class?
Yes, there is a textbook that we are using here. It's called the Analytics Edge, same title, of course. It's been written by Dimitri Bertsimas, who is the director of the program and the professor here at MIT, Alison O'Hare, and William Puliblanc. So this book is a series of case studies, extremely practical, to basically demonstrate the impact of analytics across an array of domains: healthcare, sports, finance, operations management, and so on. So we're using that, and the textbook has also an appendix with a description of analytics methods, and we're also leveraging that to get more, to basically review the methodologies. So I don't use it directly in class, but it's a very valuable resource for the students if they want to review the materials covered in class, maybe using a different perspective.
And besides you as the main faculty member, are there any teaching assistants? Yeah,
we have one teaching assistant. He is a PhD student from the Operations Research Center at MIT, which is our Center for Analytics. And it's also a very good resource for students, because they can really engage very closely with someone who's basically doing research in analytics. So Rainbow, the teaching assistant this year, basically does the recitation, the tutorials every Friday, and Rainbow and I are available during office hours and over email in order to answer the questions for the students.
Wonderful. So as a final question, what is your one piece of advice for students to do well in your class?
In the class,
in
okay.
Class.
I mean, basically, this class is trying to replicate the elements of success that would be important for like a career in analytics. And so the elements of success, I think, are threefold. One is that we need to know the methods, right? I mean, we need to know the methods of analytics, the machine learning, statistical, and optimization methods that will be helpful to actually draw some insights from the data. So that's the technical part. The second part is the computational part. We need to be able to implement these methods using computing programming in order to actually get results that make sense given the data set that we have. And the third one is the non-technical part. The non-technical part is having interest in a specific domain, being able to communicate technical results to a non-technical audience, being able to relate the results from the model to the business problem that we started with. So all of this basically softer skill set is equally important, in my opinion, for the class and then for a career. So we're trying to emphasize these three. And if you're excited about these three, come join us.
Great. Well, thank you so much, Alex.
Thank you.
That's it for this edition of the curriculum webinar for the Master Business Analytics program. Thank you for joining us.
Thank you.